14.2.1 Define capacitance. A capacitor is a component that is able to store charge. Imagine a bucket. The larger the bucket, the more charge that can be stored on it. So it's basically an ability, a capacity to store charge. This capacitance, which is measured in farads, is equal to the charge divided by the potential difference across the capacitor. C is equal to Q divided by V. An easier way to remember is Q is equal to VC. Here we have a diagram, a sketch which shows how a capacitor is structured. Now, if we have two plates here and we apply a potential difference across the plates, this side being negative, this side being positive, there will be an electric field set up between the positive and the negative plates. These plates will be quite close to each other, and therefore the positive and the negative will be actually attracted to each other, and this is why it has this ability to store charge. The closer the plates are, the charges are attracted, and therefore the more charge you can get on the plates. So it's basically defined by the geometry and the structure of the way the plates are constructed. Another way of looking at the plates is that we have a plus Q here, negative Q here. Between here we have a constant electric field and the plate separation D. If there's a small value for D, the plates are very close together and they will be able to store a large charge. So it's basically an ability to store charge, and it's measured in farads. This is a voltage, this is a cell. You close the switch and this side will become positive, this side will become negative. And the amount of charge that it supplies, that it's able to store, depends on the capacitance of this capacitor and on the voltage that's applied. If we place a resistor, the same thing will happen, but it might take a while for the current to flow on here. It might take a while for the charge to flow onto the capacitor. The larger the resistor, the slower the flow of charge. But nevertheless, eventually it will reach same as a battery voltage. So find the charge stored on a 3 microfarad capacitor if 240 volts is applied across it. So Q is equal to VC, V times by C, and there you have it. Estimate the time for the charge calculated to flow through a 60-watt bulb. We know the voltage, we can work out the current. If we know the current, we know how much charge is flowing per second. This is going to be the initial current, by the way. So it actually is going to take more than this, because as the charge builds up, then it builds up slower. And these are the values you should end up with. Q is equal to VC. We end up with 7.2 times 10 to the minus 4 coulombs. What about the charge? Well, if we know the power, we know how much current is flowing, in other words, how much charge is flowing per second. So the charge per second is equal to the current. The CCD, the charge coupled device. We have to describe the structure of a charge coupled device. It's basically a CCD is a silicon chip divided into small areas. Each one is called a pixel, and each pixel behaves as a capacitor. In a CCD, we have silicon chips divided into pixels. Each pixel behaves as an individual capacitor, which means it stores charge. And you need to know that the charge is generated by an effect called the photoelectric effect. So, when light lands on the surface of the CCD, each element, or each pixel, generates a charge which is proportional to the intensity of the instant light. In other words, the more light that arrives, the more photons that arrive, the more charge that is generated. Each pixel converts light energy into electrical energy using the photoelectric effect. More photons, which means more electrons. Now, each pixel is able to generate a charge which depends on the light that has been falling on it. Each pixel acts like a capacitor and it builds up the charge, which depends on the photons that have fallen on that pixel. When the light falls on the pixels, it stores charge in the same way that these buckets are able to store water, like rainwater. When the rain has fallen on each bucket has a slightly different amount of water in, because it represents the light that has fallen on it. Then it's on a conveyor belt. So we need to measure the amount of water, weigh the amount of water in each bucket. First of all, the buckets move to the right on this conveyor belt, and then on another conveyor belt where each one is measured. So these move this way, and then there's another conveyor belt which measures the weight of each one. This happens around 30 times a second for the whole CCD. And this shows, this is an animated GIF showing the same thing. All the buckets move down, and then there's a horizontal register here where the content of each bucket is measured, is weighed. As charge is shifted line by line to the serial register, this is called the serial register, and then the charge is transferred pixel by pixel to a device that measures it, a voltmeter of some kind. Then this voltage is turned into a digital value. A little bit of history. It was basically developed in 1970 by Boyle and Smith, and then they got the a Nobel Prize for Physics a few years ago, actually, about 35 years afterwards, after they developed the CCD. Summary. Charge is generated by the photoelectric effect. This charge which is collected on the pixels. Then the packets of charge from each pixel is moved downwards on these vertical registers to the horizontal register. Then from the horizontal register, these packets of charge are measured by a voltmeter and converted to an output voltage, which is digitized. Here's another graphic which shows this. This is the CCD. As soon as the picture is taken, all these packets of charge move down to the serial register, and then they move this way, and each packet is read individually, amplified, and turned into a digital signal. Students are only required to know that an electrode measures the potential difference developed across each pixel, and this is then converted to a digital signal. The pixel position is stored by the time that it arrives at the output gate. So charge is collected from each pixel, transferred by coupled charges from one pixel to the next in turn as it moves down. So, in summarize, generation. Charge is generated by the photoelectric effect, and that's where the charge is generated. Then it's collected. The charge is collected on the pixels. Then it's transferred down the vertical register to the horizontal register. Then these packets of charge are measured by an electrode, by a voltmeter. And then this signal, this value for the voltage, is digitized.